So the last question, which is question C, we're given the same another kind of homogeneous differential equation, and then we're told to solve non-homogeneous differential equation. So we are told to solve this using the same variation of parameters. Now, as usual, we know that the general solution should be of the form yc plus yp. So I'm going to start by finding yc, that's the complementary function. So the first step, you solve for yc. So yc is the associated homogeneous. See, I'm mentioning the associated homogeneous just for emphasis and for the thing to register in the memory. That's why I've been saying it over and over again. So the associated homogeneous differential equation is y prime prime plus 4y prime equals 0. Now to solve this homogeneous equation, we start by solving the auxiliary equation. That's m cubed plus 4m equals 0. And then this is the same thing as m into m squared plus 4 equals 0. So when you solve this, what we obtain is m equals 0 and m equals plus or minus 2i. Now that's what we get for our solution. And based on what we have as the solution of the auxiliary equation, so that implies that the complementary function will be yc equals c1 times 1 plus c2 sine of 2x plus c3 cosine of 2x. Let me put all these linearly independent functions in braces so that we'll clearly see how we're going to make a substitution to implement the variation of parameters method. Now the second step is solve for yp. So we want to solve for yp. How do you solve for yp? So the first thing is we need an assumed form for the yp. So the assumed form says all your constants, make them functions of x. So we're going to start by saying u1 times 1 plus u2 times sine of 2x and then plus u3 times the cosine of 2x. So that's all this is. So the only change here is just the constant and then replace with functions of x. So and then where are u1? So the derivative of u1 equals w1 all over w. Derivative of u2 is w2 all over w, and the derivative of u3 is w3 all over w. And then we said the Wronskian, which is w. We said w is the Wronskian of the linearly independent functions that we have here. That's the Wronskian of 1 sine of 2x cosine of 2x. And that is just the determinant of the 3-square matrix, starting with 1, the functions themselves, the cosine of 2x, then the derivative of 1 is 0, the derivative of sine 2x is 2 cosine of 2x, and the derivative of cosine 2x, that is minus 2 sine of 2x. So similarly, we find this, we find the derivative of that, that's minus 4 sine of 2x, and then that is minus 4 cosine of 2x. So this is what we obtain, and then when we simplify this, so this gives us, that's going to be 1 into, so we have this off, so we have 2 cosine of 2x minus 2 sine of 2x minus 4 sine of 2x minus 4 cosine of 2x. So when we multiply this by this, so what we would have is minus 8 cosine squared of 2x, then this by this is going to give us minus 8, so this times this minus this times this, minus 8 sine squared of 2x. So you could factor out negative 8 out. So factoring that out, we have negative x into cos squared of x, cos squared of 2x, plus sine squared of 2x. So according to trig identities, this one here goes to 1. So our answer is -8. So similarly, we want to find W1. So to find W1, we said we should ensure that the differential equation is in standard form. So it's already in standard form. You can see the coefficient here is just 1. So it's in standard form already. So as we've done so far, as we've been doing so far, we replace the first column with 0, 0, and then the right hand side. The right hand side of the d is sec 2x. So this is going to be my f of x. So that'll be sec 2x. So let me maintain the column using sec 2x. And then you leave the other ones the way they are in the Wronskian. So you have sine 2x, 2 cosine of 2x minus 4 sine of 2x. And then the other one, you leave it the way it is, 2x minus 2 sine of 2x. And then the other is minus 4 cosine of 2x. Yep. So when we take the derivative of this, so this is going to give us sec of 2x into, so we cross this, so we are left with sine of 2x, cosine of 2x, 2 cosine of 2x, and minus 2 sine of 2x. I don't mind that. So this is going to give us sec, let me write sec 2x. So we multiply this by this, and then we subtract it from this. So we would have minus 2 out there. So this should be minus 2 sec of 2x. Anyway, this is for W1. And then for W2, instead of the first column, we move to the second column and then leave the first and the third the way they are. So that's what we have is, so the first is, this is the original first. So we change the second to 0, 0 sec of 2x. Then we have cosine of 2x minus 2 sine of 2x minus 4 cosine of 2x. So this is exactly what we have. And then when we simplify this, so we have this left. So we have 0 sec of 2x into minus 2 sine of 2x minus 4 cosine of 2x. So this times this is 0 minus this times this. So that will give us 2 sine of 2x times sec of 2x. So sine of 2x, that's 2 sine of 2x times, now sec is the same thing as 1 all over cosine of 2x. So this gives us 2 tan of 2x. So lastly we find W3. Now W3, which is just going to be, leave the first and the second, but replace the third column. So this will be 1, 0, 0. Instead I should leave the second, sine of 2x, 2 cosine of 2x, minus 4 sine of 2x, while the third is replaced with 0, 0 sec of 2x. Then the same thing we've been doing, when we simplify this, we have 2. So to find u1, so which is the new one, we'll start finding now. So since we know that u1 prime equals w1 all over w, so that implies that u1 is going to be the integral of w1. So what's our w1 here? So our w1 is minus 2 sec of 2x divided by w, which is negative 8. So that's minus 2 sec of 2x divided by negative 8. And then this, so dx. And then this gives us 1 over 4 into minus half ln of cosine of x minus sine of x plus half the ln of cosine of x plus sine of x. So similarly, u2 will be the integral of w2. Our w2 is this. So that's 2 tangent of 2x divided by minus 8. And then that gives us 1 divided by 8. So the ln of the cosine of 2x. And then lastly, u3, which is equal to the integral of, so our u3 is w3 all over w. That's 2 all over, so there should be a dx here. 2 all over 8 dx. And then this gives us, so minus 8, this gives us minus 1 all over 4. 1 over 4x. So now we have gotten u1, u2, and u3. So I can now substitute my u1, u2, and u3 into this place here, so I can find yp. So on making that substitution, I have my general solution to be y equals, so my yc, which is what we originally got to be c1 plus c2 sine of 2x plus c3 cosine of 2x. That was what we got. Then plus yp after the substitution. So what we get is for our yp, that's going to be the first one, which is u1. This is my u1 here, so that will be 1 over 4 into, it's quite long, half ln of cosine of x minus sine of x plus half ln of cosine of x plus sine of x times, okay, that's plus plus the next one, which is sine of 2x into my u2. So this is my u2 here as 1 over 8 the ln of cosine of 2x, and then lastly plus cosine of 2x into my u3. This is my u3 here, minus 1 over 4x. And then this is the general solution of the non-homogeneous differential equation post above.